In this module, we're going to look at migrating databases from an on-premise SQL environment to Azure SQL database. First, we're going to look at some of the tools that are available to evaluate your on-premise databases to make sure that they're compatible with Azure SQL database. Then we're going to talk about some of the compatibility issues and some of the things that could prevent an on-premise database from being migrated to Azure SQL database. Then lastly, we're going to look at the process for migrating those on-premise databases to Azure SQL database and some of the options that are available for both being allowing downtime for the migration and then options that are available where you can't have any downtime with the on-premise database. So when we look at migrating databases, especially when we're looking at migration databases to Azure environments, one of the things that you need to look at is there going to be some problems with objects or code that you're going to migrate into the destination environment? So we have several tools to help us identify compatibility issues that we might have with databases that we're trying to migrate to Azure SQL database. SQL Server Data Tools is a component of Visual Studio, and that will identify potential issues. It'll also give us the ability to fix those issues as part of the SQL Data Tools component. So you can see right here, when we want to do a fixing detected issues, we can actually do that right inside SQL Data Tools. What it's going to do is let us modify the transact SQL. We can use SqlPackages. SqlPackage is a command line tool that lets us export data, export schema information from an existing database, and then use that tool to import it. So Azure SQL Database has the ability to import DACPACs or BACPACs. DACPACs is just the schema, BACPACs include the actual data. We can also use the export data tier application wizard that's part of the migration tool that we talked about previously. Now it's important to note in this slide here, you see two references to the SQL Azure Migration Wizard. That's actually no longer available starting in SQL Server 2017. That functionality is actually now built into the Database Migration Assistant. So we actually have a separate tool for that now. Now when we are looking at the data migration and the results of the evaluation, we can fix some of these detected issues using different tools. I already mentioned we have Visual Studio that we can use. We can use the Database Migration Assistant, which is what the Azure Migration Wizard is actually a part of now, the downloadable tool that we talked about previously. We can also use Management Studio. Now with Management Studio, it's going to be a lot more work. It'll show us some of the problems, but pretty much all the fixes are on us. There's not going to be any automated processes for cleaning up that mess. So then what we can do is we can perform the migration. Again, for Azure, it's going to be the Database Migration Assistant that's going to help us migrate databases. We will choose Azure SQL Database as the destination. We could also use BACPAC files. And I mentioned previously, BACPAC files are exported packages that include the schema of the database as well as the data from that database. We could choose just to export the schema, which would then create a DACPAC file. So the SQL Server Data Tools for Visual Studio, SSDT, is a downloadable add-in to Visual Studio. And essentially what it does is it adds some extra functionality for integration between Visual Studio and SQL. What you want to make sure is you have the latest version, because different versions are going to add different support, and as new components come out and new versions come out of SQL, it'll make the compatibility between Visual Studio and SQL more aligned. Once you have the SSDT and the latest SSDT downloaded and installed with Visual Studio, you open Visual Studio and you add the server that you want to check for compatibility and possibly migrate to the SSDT. So you open the SSDT tab, you add in that server. Once you add in the server, you create a project for that server. And you're going to do it for a single database. This is done on a per database basis. It can't look at all the databases for you. You have to add each one manually and do each project separately. You import that database into the SSDT. Now, you're going to have permissions to that database in order for you to bring in the schema and the properties of that database. Once you do that, if your target is Azure, which in our case it is, you specify the target server to be Azure version 12. and that's the current version of the Azure SQL database. And that will then build the project, and it'll check the compatibility of all the objects in that database and list any errors, and also list some fixes that it will automatically implement for us. Now, as we talked about previously, we can alter what it fixes, and we have a little bit of control over each of the individual problems that it finds. So another tool that we can use to check for compatibility is SqlPackage. And we've seen this already when we talked about migrating and upgrading user databases. So we've already looked at this before. You should always make sure you have the latest version of SqlPackage to make sure you have compatibility with the current versions of databases. What it will do is, in this option, because we're looking at the export option, it's going to create a list of compatibility issues. Now in this example here, the source is going to be SQL Express. It's going to be the AdventureWorks database in SQL Express, and you have to export at least one file. So it's going to export the table dbo.errorlog into the export file, but it's going to do a compatibility check for the entire database, and it's going to record the information message and the error messages in the report. That's the 2 greater than &1 that does that. What this will let us do is, through a set of command lines, create exported reports that allow us to identify compatibility issues and then determine what we need to do to try to make those compatibility changes that we want to modify and put into the Azure environment. So another tool that we can use to check for compatibility is the data tier application export wizard. And what we're going to do here is we're going to export just a report. So when we do this, this is always done from the SQL Server Management Studio, and you will click on a database, and you will right-click on the database, and you will create a data tier application export. When you do that, you configure the BACPAC file. Where is it going to store the BACPAC file and the results? But because we're just checking for compatibility, we're not going to export any data. So we actually tell it, don't export any data. When it's done the wizard, it'll check compatibility, and it'll just tell us if there's any compatibility problems with objects in the database, but it won't actually try to export any data that we're then going to import. We use that report to identify fixes that we need to do. Once we implement the fixes of the source database, we could then use the same wizard to extract the schema of the database and all the data of the database that we could then import into the Azure SQL database environment. In this demonstration, we're going to look at how to use SqlPackage to verify the compatibility of an on-premise database for SQL in Azure. In this demonstration, we're going to look at how to use the SqlPackage utility to determine and verify that database and objects within that database are compatible to be migrated to Azure. So the first thing we need to do is get to the location where the tool has been installed. Now the tool has to be downloaded, it's not installed by default. So we're going to go to the location where this tool is going to be, and we're going to go to the, first we need to open up a command prompt. So we will open the command prompt here. And then we have to go to the location where the tool exists. So cd program files x86 Microsoft SQL Server '13 BAC bid. So this is where the SqlPackage is. So if I do a dir s star, that might give me more than I want. But nope, there's the SqlPackage utility, and there's the configuration file for how it runs. So what we're going to do is we're going to enter in a command here, SqlPackage.exe. The action we're going to do is export. The source server name is Miami SQL. That's the name of our SQL server. The source data name is test.psdb. That's the database where the data is we're going to pull from. The target file where we're going to save the output is going to be our D drive, demo files, mod 08.
T-SQL compatibility .BACPAC. The data that we want is going to be the table data, and the table data we want is going to be the stats.tests table, and we want to put that, we want to create an error report, so we want to send the output to d:"demo files mod 8 export report.text, and we want to make sure we get all of the data, so that's 2 greater than ampersand 1. So we'll hit enter and hope we didn't have any typing mistakes. So then we'll look at the file that we created. So we'll say notepad d:"demo files module 8 export report. And there's the export report. So it extracts the schema, makes sure that everything is validated, and then it successfully exported the information to the BACPAC file. What that now gives us the ability to do is we can use that BACPAC file to import this table into a database in Azure.
In this demonstration, we got to see how to use the SqlPackage utility to verify the compatibility of an on-premise database with Azure SQL. We also got to see how to look at the output of the log to identify the compatibility issues that might be present. So when we look at some of the significant differences between SQL Server and Azure SQL Database, probably the most glaring difference is that with SQL Server, you manage the entire environment. And they mention here that it executes on-premise. We already talked about this. It doesn't have to. I can run SQL Server in Azure on an Azure virtual machine. So it doesn't actually have to run on-premise, but you have complete control over the environment, and more importantly, you are responsible for the entire environment. So as they look here, you have to maintain the operating system, you have to maintain the hardware, you have to maintain all of the databases, including the system databases, which is something you don't have to do when you use Azure SQL Database. With Azure SQL Database, Microsoft is providing the servers, they're providing a very controlled copy of a master database. They're controlling the hardware, they're doing all the updates, they're doing all the patching for all of the servers and the applications that are involved. It runs in the cloud, it runs in Azure. It's their delivery of SQL as a platform as a service, or sometimes people refer to it as software as a service. You only maintain the user databases. And even in that scenario, you're limited in what you can do with this. An example that they give in your text is with SQL on-premise, if you want to provide redundancy for your data, you're going to set up some method of failover clustering, and we can do server-based clustering, or we can do always-on availability. And with always-on availability, we're creating multiple copies of our databases across multiple SQL servers. With Azure SQL Database, you don't have that option because you can't manage the server-level environment. You can't install the failover clustering service. So what you do is you use the geo-redundancy features that are implemented through Azure SQL Database to provide copies of your database across different servers that are running in different data centers in Azure. So before you attempt to move your databases to Azure SQL Database, you need to understand some of the features that you can't do inside Azure SQL Database. Now remember, you have to think about this concept here. You have to understand the difference between Azure SQL Database, which is essentially a database running on a server. You have minimal control over the server itself. You have complete control over the database, versus an Azure virtual machine that you've set up and you completely control the server and the database. So inside Azure SQL Database, you can't attach a database, all right, because you can't manage the server itself. Now, you can import a database. You can use the database migration assistant to migrate a database. You can use BACPAC files to import a database. You just can't attach a database. You can't use CLR code. You have no control over the server functions. You can't do snapshots of the database. Again, you have no control over the data files themselves, which you would need access to in order to be able to create database snapshots, attach databases, do backup and restore. None of those features are available to you. An important note that I want you to understand, prior to SQL Server 2017, you were not able to do always-on availability in Azure SQL databases. You can now do that, and you no longer can manage data quality services, again, starting in 2017, but you used to be able to do that prior to Azure SQL databases in 2017. Another important note to think about in some of these things is some of the services that are not available. So the SQL agent functionality, the database mail functionality, database mirroring, none of those features are available because, again, what you're looking at is you're looking at things either at the server level, managing properties or processes at the server level, or managing the actual data files themselves, which you have no control over when you have an Azure SQL database. So in addition to some of the features that we can't do in Azure SQL database, there's some parameters and properties that we can't use in Azure Transact SQL statements. We can't do anything regarding ownership chain management, so we can't do cross-database ownership chains. We can't control the collation of the system objects. Now, when you create the database, you can define the collation for the database, but you can't control the collation of individual objects within the database. They're always going to inherit from the database. You can't modify the database properties. Again, that's because that information is going to be stored in the master database. You can't execute as a specific login, again, because we really don't have access to the login details in the master database. You can't control events and notifications, no access to the SQL agent service. You can't manage the database files. Again, all of that information is done in the master database, so any Transact SQL statements that attempt to manage the files, we don't have any options with. You can't use hasDB access. You can't say kill stats job. You can't use any of the open options within the Azure SQL database, so no open row set, no open query, no open data source. We already talked about log shipping and minimal logging. You can't do either of those options, so you can't reference any commands related to those. You also can't do set remote procedure transaction actions. You can't do a shutdown, right? You can't manage the server, so you can't do a shutdown. Now, it's important to note, you can stop the SQL Server in your Azure tenant, so I can actually turn it off, but I can't really issue a shutdown command inside my Transact SQL. You can't use SP help user, again, because of the lack of ability to access the master database. You can't use the use statement. So for those that might be old school, and remember, if you want to run a command, Transact SQL statement in a specific database, you say use the name of the database. Well, this is a database. You're not managing the server, so it's always going to run against your connection point to whatever the database is. You also can't do debugging for your Transact SQL statements, and you can't implement any trace flags. Trace flags are normally implemented at server level components. Even though there are some database trace flags, we can't implement the trace flags in our Transact SQL statements in Azure SQL Database. So as they come out with new versions of SQL Server, some things just go away, and it's just the way it is because some functionality just doesn't make sense anymore, and it isn't effective, and it doesn't really work in real-world scenarios. So we'll work backwards from the way this slide is set up. So from SQL 2012 and SQL 2014, right down here at the bottom, some of you may recognize this, others of you may not, but this is the old way that we used to write join statements, right? So this would be a left outer join, this would be a right outer join. No longer supported starting in SQL Server 2012. Compute and compute by you can't use starting in SQL 2012. Instead, you would use rollup with rollup. SQL Mail has been replaced by SQL Database Mail, so it now works a different way. No longer does it have a tight integration with Exchange servers and Outlook clients. Now it's just simply an SMTP client. The SPDB option store procedure is actually missing now, so instead you're actually going to set the properties of the database. The with append clause is done on triggers. We have different methods that we have now for triggers where we can look at different functions with triggers for things like for functions, so for update. The ability to use a proprietary version of an external storage engine called VIA is gone starting in SQL 2012 and SQL 2014. And they also mentioned that the database levels. So as we get newer versions, older versions are no longer supported. So here, this right here, the 8.0 would be SQL 2000. So no longer compatibility levels for SQL 2000. And this would be SQL 2005. So this, the 8.0 would be with 2012. Starting in SQL 2016, again, 32-bit installations are no longer supported, and ActiveX controls are no longer capable inside the SQL agent service. So we no longer have the ability for the ActiveX subsystem in order to be able to use the process for running commands with inside SQL job steps. The only real big change that we have to deal with in SQL 2017 is that there's no longer integration with SharePoint for the reporting server services. Now instead, we're going to use the Power BI functionality that we have. So Power BI Report Server is the component that allows us to replace the integration piece with SharePoint. So when we look at doing migration of databases from an on-premise environment to Azure SQL database and even other types of environments, we have lots of different tools that we can use that we've already looked at extensively throughout this module. But some of the things you got to take into account is what is the allowable downtime for the particular database that we're attempting to migrate. And most of the tools here that we look at involve downtime. In other words, you can't be accessing the database while we're migrating it, because what will happen is any changes that occur in the database after the export process will not be included in the import process of the destination database. So if you have a little bit of allowable time, small to medium businesses, small to medium databases, you don't have an e-commerce database, you can use tools like SqlPackage to export the SQL Server migration, SQL Server Management Studio migration tools and migration wizards. We can use those, but all of those are going to create essentially a snapshot in time of the data set, which means that any changes that occur after that will not be seen in the copy that we put on the Azure database environment or wherever we're migrating the database to. The solution for that would be to use transactional replication. With transactional replication, we end up with essentially a transaction that becomes a multi-phase commit operation. So it isn't fully in the database until it's been acknowledged in both places. So what ends up happening here is we have the data that gets modified in the source will eventually get modified in the destination by looking at markers essentially in the transaction log that identify what has changed and what has already been copied over to the destination. By setting up transactional replication, which we can set up between an on-premise database and an Azure SQL database, we can actually configure it so that this transaction that occurs here will eventually occur over here, even though I've done a backup. Now, when you do transactional replication as a general rule, there's all kinds of issues and not issues, there's all kinds of options that we have for seeding the copy. But typically what we're going to do is something called a snapshot. And so we're going to start with a snapshot, which is basically almost like a backup and restore operation. And it's going to create that database at that particular point in time. That's why it's called a snapshot. Then it's going to keep track of the transaction log. And as changes occur in the transaction log, it's going to copy those changes to the transaction log of the destination database, and it's going to replay them the same way it would have replayed them on the original if we'd done something like a restore operation. So when we set that up, The big advantage is that we can turn this on, and then after the initial snapshot, after it copies the data, it's then going to bring it up to speed based on the timing. So we can have both databases live until they're brought all the way up to speed, and then we can turn off the on-premise one. Now here we are looking again at the SqlPackage command, the SqlPackage tool that we have. What this allows us to do is use the SqlPackage utility to create either DACPACs or BACPACs. The difference between a DACPAC and a BACPAC is the DACPAC is just the schema of the database, whereas the BACPAC is the schema and the contents of the database. So what it's going to do is it's going to create the file structure, the schema of the database. You use the SqlPackage command. If you want to create a DACPAC, the action will be extract instead of export. Otherwise, it's exactly the same. Here it's going to grab it from a SQL Express instance from the AdventureWorks database, and it's going to create the BACPAC file. Once the BACPAC file is created, there's a command line tool that we can look at, which is kind of interesting. It's called DACUnpack with a K, to view the XML file that's actually created. Then what we do is once we evaluate and make sure the data is what we want, we use the SqlPackage with the import operation, and notice the target server is the connection string to connect to your Azure SQL database. Remember, we talked about this before, you're going to have set up whatever IP address you're on to allow to go through the firewall to connect to that environment. Then you specify the source file, SF, you specify the database edition that it's going to create, and the database service object that it's going to put the information in. That's going to be your tier level. So it allows us to control how the environment is going to happen and how it's going to create the databases and the data if we want using BACPACs or DACPACs. It's important to note that you can also create BACPACs and DACPACs from the SQL Server Management Studio and then use the SqlPackage to import them into your Azure SQL database. So another way of getting data into a database, any database, including Azure SQL database, is the old tried and trusted bulk copy. So BCP is bulk copy. It's a command line tool. With the command line tool, you have a lot of switches. So if you've never used bulk copy before, it's a challenge to start with. There's a lot of parameters. The parameters are case sensitive, so you have to be cautious about the parameter options. The first example here, what you're going to be doing is you're actually going to be creating a format file. All right, so this is actually creating a format file here, and you can see the format is null, so we're telling it not to use a specific format file, and this is the format file it's going to create, which is going to define things like what the row terminator is, what the column terminator is. New line right there, that's going to be your row terminator. Then once you have that data, once you have that format file created, you then use the bulk copy to create the data set. So we create the output, and we're going to use the format file that we defined here, right there. That's telling it to use that format file. And it's going to create a file called Employees.bcp. So now we have all of the data out. Now what's very important to note about bulk copy is it's one table at a time. So if you have a database with 20 tables in it, you're going to have to run this command 20 times. All right? It's always one at a time. It's always one direction at a time. It's always out, or it's always in, or you're creating the format file. After we get the data out, we then do the in, and so this is going to take the employees BCP that we created here, use it as an input file to our Azure SQL database. So remember, when you set up the Azure SQL database, you're going to get a URL, a name for the server that's usually going to end in database.windows.net. You then specify the username and password that has permissions to create data in that database, and then you specify the format file that it's going to use for the input. This is old school. It works pretty much with all kinds of data sets, which is why it's still around. But as you can see, if I have 20 separate tables in a source database on premise, I'm going to have to run this thing 41 times. Once to create the format file, 20 times to get the data out, and then 20 times to get the data in. So as mentioned previously, one of the other ways that we can get data into our Azure SQL database is by using transactional replication. And the big advantage to doing the transactional replication is the no downtime. So what it lets us do is migrate the data from one source environment, which we refer to as a publisher, into another database that's going to be set up to match the on-premise database. There are three roles here. There's the publisher, which is the source data. There's the subscriber, which is where we want the data to get copied to. Now initially, the publisher will be the on-premise SQL Server. The subscriber will be the Azure SQL database. But there has to be a server that stores and maintains the changes as they occur in a special database, and that's called the distributor. The distributor role always exists in the on-premise environment on a full-blown SQL Server. It's important to note, I say on-premise, it could be an Azure virtual machine, but it's got to be in full-blown SQL Server. The distributor role is not possible in the Azure SQL database. So we have the distributor role that's been defined after the data gets copied up. So we set up replication, we define the roles, we then start the replication process. We then have to create user accounts in Azure to allow them to access the data. We wait until the changes are replicated, and I would suggest maybe, we talked about no downtime here. I would suggest maybe changing the on-premise publisher to read-only mode at some point where it's least impacted on everyone, just to make sure we get a point where we know all the changes have been received. We then make sure that those changes have been replicated up to the subscriber, up to Azure SQL database, and then we can flip the roles. Now they mentioned here you can simply uninstall transactional replication. You can stop the replication. If you want to have a mirrored copy of your Azure SQL database, you can continue the replication and flip the roles and have Azure SQL database running as the publisher and have your SQL Server, on-premise SQL Server running as the subscriber, or you can simply remove the replication feature. In this demonstration, we're going to look at how to use SqlPackage to create a BACPAC file for migrating an on-premise database to Azure SQL database.
In this demonstration, we're going to use the SqlPackage utility to export a database from an on-premise SQL Server and then import that BACPAC file into Azure SQL. So the first thing we're going to do is we're going to export. Now, I've already run this command, so we're going to go up a couple of times. So this right here is going to be the export. So you can see we're going to use SQL BACPAC. The action is export from Miami SQL from the test PSDB, and the target file is the tsql export BACPAC file. So what that's going to do is similar to what we saw in the previous demonstration. It's going to check the schema, it's going to extract the schema information, and then it's going to extract the tables and the data that's in the tables. After that is complete, I have created another little file here that we're going to use as the input for putting the data into our Azure database. Now, in this example right here, this is going to pick up all of the information, so I'm going to copy this. Now, before I paste this in, what I want you to see is right here is our Azure database, and you'll see that we don't have any tables in the test PSDB. So we'll refresh this, right, and you will see that there are no tables in there. So now we'll go back to our command prompt, we'll paste in the command, and you'll see that again it's SqlPackage. The action now is import. This is my Azure SQL Server. This is my user account. Now you'll notice the little carrots here. The $ is a special character, so we can't use that. We have to escape it to tell it that we actually want to use the $. And this is the source file that we're going to import from. So we'll hit enter. It'll start the connection. It'll initialize the deployment to connect to the server. So they tell you that there might be an issue with some compatibility issues depending on the platform that you've chosen with your Azure SQL database. and that's going to go through the import operation. Now, it's important to note that there are other ways to accomplish this. We could use SQL replication. We can use attach, detach database options. So there's other ways of getting our data from our on-premise Microsoft SQL Server to an Azure SQL Server. So our process is moving along very well. It's verifying, and then now it's importing the schema and updating the database, and there's the import of some of the data, but you'll notice that it's disabling indexes, and then it's processing the different tables and the data from those tables, and then it's re-enabling the indexes, and now it's complete. So now if we go over to our Azure SQL database, here's our test DB. Now remember, we just did this through a script, so it won't automatically refresh, so we'll click refresh, click on tables, and there's all of our tables. So that is how you export data from an on-premise SQL Server into a BACPAC file and then import it into an Azure SQL database.
In this demonstration, we got to see the process for using SqlPackage to create an Azure to create a BACPAC file that we then got to see how to import that BACPAC file to create a new database in Azure SQL Database. In this lab, you're going to go through the process of migrating a SQL Server on-premise database to Azure. You're going to start off by using the data tier application methodology to verify the compatibility of an on-premise database. You're going to view the output of that log to identify the problems that might prevent that database from migrating to Azure. And then you're going to fix those issues, and then you're going to migrate that database to Azure. This lab should take about 45 minutes.